What is the primary goal of using semi-supervised learning in a machine learning scenario? To achieve higher accuracy by leveraging a small amount of labeled data along with a large amount of unlabeled data. To reduce the reliance on labeled data, which can be expensive and time-consuming to obtain. To improve the model's generalization ability by exposing it to a broader range of data patterns. All of the above. To achieve higher accuracy by leveraging a small amount of labeled data along with a large amount of unlabeled data. This statement is correct. Semi-supervised learning aims to utilize both labeled and unlabeled data to enhance the performance of machine learning models, resulting in higher accuracy even with limited labeled data. The unlabeled data helps the model learn more robust data representations. True. To reduce the reliance on labeled data, which can be expensive and time-consuming to obtain. This statement is also correct. Semi-supervised learning strives to minimize the dependence on labeled data, which is often costly and time-intensive to collect. By leveraging unlabeled data, which is typically abundant and readily available, these methods can achieve satisfactory results. True. To improve the model's generalization ability by exposing it to a broader range of data patterns. This statement is also correct. Semi-supervised learning techniques improve a model's ability to generalize to unseen data by exposing it to a wider range of data patterns through unlabeled data. This leads to more robust and reliable predictions. True. All of the above. This is the correct choice as it encompasses all the advantages of semi-supervised learning. Semi-supervised learning achieves higher accuracy, reduces reliance on labeled data, and enhances generalization ability, making it a valuable approach in various machine learning scenarios. True. D. Supervised learning. A type of machine learning where the model is trained on a dataset with labeled inputs and corresponding outputs. The goal is to learn a mapping between inputs and outputs. Predicting the price of a house based on features like size, location, and number of bedrooms. Unsupervised learning. A type of machine learning where the model is trained on unlabeled data, aiming to discover patterns and structures within the data. Clustering customers based on their purchasing behavior to identify different segments. Label propagation. A semi-supervised learning technique where labels from labeled data are propagated to unlabeled data based on their similarity. In image classification, if a small number of images are labeled as dog, the algorithm can propagate the dog label to unlabeled images that share similar features. Label spreading. A specific implementation of label propagation in sklearn, a popular machine learning library. The provided code snippet demonstrates how to use label spreading in sklearn to classify data points in a 2-moon dataset. Kernel. A function that measures similarity between data points. Different kernels can be used depending on the nature of the data and the desired similarity measure. In the example code, KNN kernel is used, which stands for k-nearest neighbors. This means the similarity between two data points is based on their proximity in the feature space. Alpha. A parameter in label spreading that controls the balance between label smoothness and fidelity to the labeled data. A higher alpha value emphasizes label smoothness, while a lower value prioritizes fidelity to the labeled data. In the example code, alpha is set to 0.2, indicating a moderate balance between smoothness and fidelity. Image classification. Semi-supervised learning can be used to classify images with limited labeled data by leveraging a large dataset of unlabeled images. The algorithm can learn from both the labeled and unlabeled images to improve its accuracy and generalization ability. Classifying images of different types of animals, where only a small number of images are labeled, while a vast dataset of unlabeled images is available. Natural language processing. Semi-supervised learning can be applied to analyze text with limited labeled data by utilizing a large corpus of unlabeled text. The algorithm can learn from both labeled and unlabeled text to improve its understanding of language patterns and perform tasks like sentiment analysis or topic extraction. Analyzing customer reviews to determine their sentiment positive, negative, neutral using a small set of labeled reviews and a large corpus of unlabeled reviews. Fraud detection. Semi-supervised learning can be used to identify fraudulent transactions with limited labeled data by leveraging a large amount of unlabeled transaction records. The algorithm can learn from both labeled and unlabeled records to detect anomalies and patterns associated with fraudulent activities. Identifying fraudulent credit card transactions using a small set of labeled fraudulent transactions and a vast dataset of unlabeled transactions. 1, 2, 2, 3, 3, 1, 4, 2, 5, 4, 6, 5, 7, 3, 8, 4, 9, 2, 10, 3, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 1, 2, 1, 2, 3, 1, 3, 1, 0, 4, 2, 0, 5, 4, 1, 6, 5, 1, 7, 3, 8, 4, 9, 2, 10, 3. In this example, we have a dataset with 10 data points each represented by two features X and a corresponding label Y. We assume that we only have labeled data for the first 6 data points. Using semi-supervised learning, we can propagate labels to the remaining unlabeled data based on their similarity to the labeled data.